Imagine a visitor traveling through space for millions, maybe even billions of years. This visitor is not from our neighborhood. It is not from around our sun. It comes from a distant star far, far away in our galaxy. This is the story of a very special object named 3I/Atlas. Scientists are so excited about it because it is only the third object we have ever seen that has come from outside our solar system. We call these visitors interstellar objects. They are like messengers from other star systems, bringing secrets from their long journeys across the vast dark emptiness of space. This cosmic traveler was first spotted on January 7, 2023. A powerful survey system in South Africa called ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, found it. At first, astronomers thought it was just another comet from our own solar system. But as they watched it more closely, they noticed something very strange about its path. It was moving too fast, and on a trajectory that showed it wasn't orbiting our sun. Its path was a clear sign that it had traveled from another star system and was just passing through ours on its incredible interstellar adventure. The discovery of 3I/Atlas was a huge moment for science. We have only known about 2 other interstellar visitors before it. The first was Oumuamua, a strange cigar-shaped object seen in 2017. The second was Borisov, which looked more like a typical comet, in 2019. Now, with 3I/Atlas, we have another chance to study a piece of another solar system up close. Each new visitor is a precious opportunity. It helps us understand if our solar system is unique, or if there are many others like it out there in the big wide universe. Studying these objects is like being a detective. We look for clues to solve the mystery of where they came from. Did 3I/Atlas come from a solar system with planets like ours? Was it kicked out of its home by a giant planet? Or was it born in a different way altogether? These are the exciting questions that scientists all over the world are trying to answer. By looking at what 3I/Atlas is made of and how it behaves, we can start to piece together the story of its distant home and its long, lonely journey to our corner of the galaxy. To solve the mysteries of 3I/Atlas, scientists needed the best tools available. They pointed some of our most powerful telescopes toward this new visitor. It was like a team of superheroes assembling to study the alien object. The first hero was the Hubble Space Telescope. Hubble has been our eye in the sky for many years. It can see things in amazing detail. Hubble looked at 3I/Atlas to see its shape, size, and what kind of dust was coming off it. Its sharp vision helped us get a close-up look at the cloud of gas and dust, called a coma, that surrounded the comet's core. Next up was a new and mighty telescope, the James Webb Space Telescope, or JWST. This telescope is special because it can see infrared light. This is light that we cannot see with our eyes, but it's perfect for studying cold objects in space. JWST looked at 3I/Atlas to figure out what it was made of. It analyzed the gases that were escaping from the comet. This helped scientists understand the chemical recipe of this interstellar object. The information from JWST was like reading the ingredients list on a package from another star system, giving us clues about its origins. 2 other important telescopes joined the team. One was the Transiting Exoplanet Survey Satellite, or TESS. TESS usually looks for planets around other stars, but it is also great at watching objects for a long time. TESS watched 3I/Atlas to see if its brightness changed. This could tell us how fast the comet was spinning and if it was tumbling through space. Then there was SPHEREX, a mission designed to map the entire sky in infrared light. It looked at the water and other molecules around 3I/Atlas, helping us understand how much ice it was carrying on its long journey. Working together, these 4 amazing telescopes gave us a full picture of 3I/Atlas. It's like having 4 different experts look at the same problem. Hubble gave us the sharp visuals. JWST told us about the chemicals. TESS watched its behavior over time. And SPHEREX measured its water content. By combining all this information, scientists could learn much more than they could with just one telescope. This teamwork is how modern science makes big discoveries, especially when we are looking at something as rare and mysterious as a visitor from another star. When scientists looked at all the data from the telescopes, they found that 3I/Atlas was not a normal comet at all. It was very, very strange. One of the biggest surprises was what it was made of. Most comets from our solar system release a lot of water as they get closer to the sun and warm up. But 3I/Atlas was different. The James Webb Space Telescope found that it was releasing huge amounts of carbon dioxide gas, but very little water. This high level of carbon dioxide is very unusual and suggests it formed in a very cold place, much colder than where our own comets were born. Another strange thing was its activity. Comets are often called dirty snowballs. They are usually frozen solid when they are far from the sun. They only start to form a glowing coma and tail when the sun's heat turns their ice into gas. But 3I/Atlas was active when it was still very far away from the sun, much farther than Jupiter. It was releasing gas and dust long before it should have been warm enough. This early activity, powered by its carbon dioxide turning into gas, was a big clue that this comet was not from around here. It behaved by a different set of rules. Perhaps the most bizarre feature was its shape. Comets usually have two tails, a bright dust tail and a fainter gas tail, both pointing away from the sun. But Hubble's images showed something different for 3I/Atlas. It had a big, bright coma, but it was shaped like a teardrop. It did not have a classic long tail trailing behind it. This strange shape puzzled scientists. Why didn't the pressure from the sun's light and solar wind push the material into a long tail like it does for other comets? It was another mystery that made this object so unique and fascinating. All these clues, the high carbon dioxide, the activity far from the sun, and the missing tail, paint a picture of a truly alien object. It tells us that the place where 3I/Atlas was born is very different from the birthplace of our own solar system's comets. Maybe it came from a system around a smaller, cooler star, or from a region of space with a different chemical mix. Every strange detail is a piece of a puzzle. It helps us understand the amazing variety of worlds that exist beyond our own, challenging our ideas of what a normal comet should look like. The journey of 3I/Atlas through our solar system is far from over. Today, on September 12, 2025, it is getting closer to the inner solar system. Scientists are watching its every move. Its path will take it close to the orbit of Mars. Then it will swing around the sun before heading back out into deep space, never to return. As it gets nearer to planets like Mars, and even gets a gravitational nudge from the giant planet Jupiter, its path might change slightly. Observing these small changes can help us measure its mass and density more accurately, giving us more clues about what it is made of. The biggest mystery that scientists want to solve is, where did 3I/Atlas come from? By tracking its path backward through space, astronomers can try to pinpoint its home star system. But this is incredibly difficult. Space is huge, and stars are moving. It's like trying to find out which house a ball came from after it has rolled all the way across town. Even if we can't find its exact home, studying its chemistry gives us hints. The high amount of carbon dioxide suggests it may have come from a protoplanetary disk around a young star, a place where new planets are being born. This strange visitor forces us to ask new questions about our place in the universe. Are interstellar objects common? Seeing 3 in just a few years suggests they might be. If so, space could be full of these messengers traveling between stars. This could mean that the building blocks of planets, and maybe even life, could be exchanged between star systems. 3I/Atlas is like a sample delivered right to our doorstep, giving us a free peek into the chemistry of another part of the galaxy. It helps us see if the ingredients that made our solar system are common everywhere. That is why we must keep watching 3I/Atlas as long as we can. Every new observation could reveal another secret. As it continues its journey, it leaves us with a sense of wonder and a lot of new questions. How many other star systems are out there? What are they like? And are we alone, or is the universe connected in ways we are only just beginning to understand? Objects like 3I/Atlas remind us that there is always more to explore. The universe is a big, mysterious and exciting place, and we are just starting to read the messages it sends us.